Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, the concentration C at T in milligrams per cubic centimeter of a certain medicine in a patient's bloodstream is given by C at T equals 0.1 T over T plus 3 square, where T is the number of hours after the medicine is taken. And we have to determine the maximum and minimum concentrations between the first and sixth hours after the medicine is taken. Now the first step here is to write the domain or the interval for the independent variable based on the situation described in the problem. Now, as per the problem, we have to find the maximum and minimum concentration between the first and sixth hours. So that means the interval for t is greater than equal to 1 and less than equal to 6. So this is the interval in which we have to analyze the t values to determine the maximum and minimum concentration. Now, for maximum and minimum concentrations, we have to find the t values at which the tangent is horizontal, because those points represent the peak and the valleys in the graph of the function. So we'll start by finding the derivative of this concentration function. Now this function is a rational function, so we'll have to use the quotient rule to find its derivative. So the first step is the prime of C at t equals, so for quotient rule, so we start with the derivative of the numerator, which will be just 0.1 times the denominator, which is t plus 3 squared, minus the numerator expression 0.1 t times the derivative of the denominator. Now for the derivative of the denominator, we'll have to use the chain rule, because the denominator expression is a function with an inner function t plus 3 and the outer function, the exponential function, with the exponent 2. So we'll start with the derivative of the outer function, and for that we'll use the power rule. So we move the exponent to the front, so we get 2 and then times t plus 3 exponent 2 minus 1 times the derivative of the inner function, which is t plus 3, and its derivative will be 1 plus 0. So 3 is a constant, so that's why its derivative is equal to 0, and then divided by the square of the denominator. Now we can simplify the numerator expression. So prime of t equals, now in the first part we'll have to expand the square, so we can write out the t plus 3 twice, and in the second part we can multiply 0.1 by 2, so we get 0.2 t and then times t plus 3 exponent 1, but we don't write 1 as an exponent, and then 1 plus 0 is 1, and multiplication by 1 doesn't change anything, and in the denominator we get t plus 3 and the exponent becomes 4 using the power on a power law of exponent. So we multiply the exponent. Now we have to find the times at which the tangent is horizontal or the first derivative is equal to 0. So we can set the left side equal to 0, and in the numerator we can distribute the terms in the parentheses using the FOIL method. So we get 0.1, and then parentheses we get t squared plus 3t plus 3t plus 9, and then close the parentheses. And in the next part we can distribute 0.2t into the parentheses. So we get negative 0.2 t squared negative 0.6 t over the denominator. Now in the next step, we can cross multiply the denominator, so that way the denominator will go away because 0 times the term will be equal to 0. So we get 0 equals, and in the numerator we can distribute the terms in the parentheses. So 3t plus 3t will be 6t, and we can also distribute the 0.1 into the parentheses. So we get 0.1 t squared, and then 3t plus 3t 6t, so it will be just 0.6t, because 3 times 0.1 is 0.3, and then another 0.3, and then plus 0.9, and then minus 0.2 t squared minus 0.6 t, and now we can combine like terms. So positive 0.6 t and negative 0.6 t will cancel each other out, and then 0.1 t squared minus 0.2 t squared will be negative 0.1 t squared plus 0.9. Now we have to solve this equation by isolating t. So we can move the t term to the left side. So we can add 0.1 t squared to both sides. So 0.1 t squared on the right side will cancel each other out, and we get 0.1 t squared equals 0.9. Now we can isolate t squared by dividing both sides by 0.1. 0.1 on the left side will cancel each other out, and 0.9 divided by 0.1 is equal to 9. So the next step is t squared equals 9, and now we can apply square root to both sides. So on the left side, the square and the square root will cancel each other out, and we get t equals plus minus 3. Now negative 3 is outside the interval for t, so that means the only valid value for t we get is t equals 3. Now we can find the values of the concentration and the t value we just found, and the upper and the lower limit in the interval for t. So we'll start with, so t equals 1. So we have to find the concentration at t equals 1. So C at 1 is equal to, so we'll sub in t as 1 in the given function for concentration. So we get 1 plus 3 squared, which is equal to 0.1 over, now 1 plus 3 is 4, and 4 square is 16. And 0.1 over 16 is equal to 0.00625, and this is the value of the concentration at t equals 1 hour. Now we'll find the concentration value at 3. So we'll sub in t as 3 in the given concentration function. So 0.1 times 3 over 3 plus 3 squared, which is equal to 0.3 over 3 plus 3, which is 6, and 6 square is 36. So 0.3 over 36 is equal to 0.0083. Now we have to find the value of the concentration at t equals 6. So we'll sub in CS6 in the given concentration function. So 0.1 times 6 over 6 plus 3 square. So which is equal to 0.6 over, and then 6 plus 3 is 9, and 9 square is 81. And now we can do 0.6 divided by 81, which is equal to 0.0074. Now we have to compare these three concentration values to find the maximum and the minimum concentration. So the maximum concentration is this one, 0.0083. And the minimum concentration is this one, 0.00625. So now we can conclude our answer. So the maximum concentration, and we can also write the appropriate units. So maximum concentration is equal to 0.0083, and the given unit of concentration is milligram per centimeter cube. And then the minimum concentration is 0.00625, and again the same unit, the milligram over centimeter cube. So this should be the final answer for this problem. Now we just have to find the maximum and the minimum concentration. So the maximum occurs at t equals 3 hours, and the minimum concentration occurs at 1 hour. So these are the steps you have to keep in mind to solve a problem like this one. So the first thing we need to understand is that we have to find the interval based on the given information, and the interval for t in this case is the t is between 1 and 6 hours, and then we find the derivative of the concentration function to find the t values at which the tangent is horizontal. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.